Hey, good morning, Doherty Honors 3-4 students. This is Mr. Geertsma, and I am going to quickly work through this homework on page 563 that you had for this week. I thought it might be helpful to have you be able to watch me work problems out in case you got a question on one. Feel free to pause this video. Feel free to fast forward to just the problems you need. This is really just a resource for you. So, starting with problem 9 on page 563, it says, suppose the weight of a bar of soap decreases by 2.5% each time it's used. If the bar weighs 95 grams when it's new, what is its weight to the nearest gram after 15 uses? First of all, I always like to take notes on a problem like this. So as I'm reading the question, it says it decreases by 2.5%. So that's my rate, and it has a rate of decrease of 2.5%. And then it says the initial amount was 95 grams. So that's always your A. So it starts out as 95 grams when it's a brand new bar. Okay. And then finally, it says that how much would you have left after 15 uses? Now that's kind of your time on this problem, 15 uses, because they're not doing time in like minutes or seconds, they're doing it per use. So because you don't see the words compounded continuously or continuous growth or decay, this is a problem where we're going to use this formula, y equals a 1, and we'll do minus r because it's decreasing. Every time you use the bar of soap, it gets smaller, so it's decreasing. If it was increasing, obviously I would do plus, and then to the t power. Okay, so I'm really just going to pop my numbers into this formula and crank it out. So first of all, I want to find out how much of the bar is left. Y is always what's left after the 15 uses. A is always your initial amount. Sorry about my handwriting, but I'm trying to write with a glove because every time I touch it with my hand, it moves this touch screen. So basically I would put in 95 for my initial amount. And then I would do 1 minus. Now this is where you always got to be super careful. If it says 2.5%, R actually has to be in a non-percent rate. So in other words, we know that 2.5% is really 0.025, okay? So this is going to be 0.025, not 2.5. In fact, if you put in 2.5, your bar of soap is decreasing at a rate of 250% per use. You're probably scrubbing too hard if that's the problem. All right, and then 15 is your number of uses. So you would put in 15 here. That's kind of your time because it's decreasing at this amount per that use. Now, the next thing I would do is just clean up what's in parentheses. So make sure you follow PEMDAS on these problems. So 1 minus 0.025 would be 9.975. Okay, now realize what that's really telling you is that every time you use the bar, there's about 97.5% of the bar left after you take your shower or bath or whatever, okay? The next thing I would do is exponents. So I do what's in parentheses first, then I do exponents. So the next thing I would do is take 0.975 to the 15th power on a calculator. That would give me 0.6840. And then I multiply that together with 95, and I would get about 64.98. Obviously, you would round that to the nearest whole number. So about 65 grams of soap would be left after 15 uses. Okay? And by the way, this was a multiple choice in the homework, so that was answer C. All right, hopefully that helps on that one. The next thing I want to do, I'm going to erase each problem. Actually, you know what I may do is I may just slide this up. So let me see if I can just slide this up and go right to the next problem. Okay. So the next problem we're going to do is number 10. Now, number 10 said, Zeus Industries bought a computer for $2,500. That's my initial amount. Again, I like to take notes as I'm reading. It is expected to depreciate at a rate of 20% per year. So that's the rate of decrease is 20% per year. And then what will the value of the computer be in 2 years? So that's your time that's going to elapse, so 2 years. Okay. So again, I did not see the words continuous or continuous growth to continuous decay. So again, I'm going to use this formula. This is always our standard formula. Again, I'm going to put a minus this time because it's decay again. So it's very similar to the last problem. So I start out with $2,500 is what the thing is worth when I buy it. Of course, when we buy things like computers and cars, they lose value over time. They depreciate is the word you want to use. So 1 minus, now again, be careful. Do we put in 20? No, we put in 0.20 because 0.20, sorry, my two's really messed up there. Because you need to convert your percent into a decimal number, okay? And then the time would be 2 on this one. So again, what I'm going to do is just crank out the math. So you do what's in parentheses first. So that would be 0.8, which means after every year, you got about 80% of your value left. Next thing I'm going to do is do 0.8 to the second power on a calculator, and that gives me 0.64. And then I multiply those two together, and I get my value of 1,600. So if you buy a $2,500 computer, and it's depreciating at a rate of 20% per year, you would expect that thing to only be worth about $1,600. So if you want to throw it on Craigslist, that's about the fair price. Okay, moving on. Number 11 now, okay? So number 11 says, hey, how about a new color for a while? Number 11 says the Martins bought a condominium for $85,000, assuming that the value of the condo will appreciate, which means it's going to go up in value, at most 5% a year. How much will it be worth in 5 years? So again, I take notes. Initial value is $85,000. It's appreciating, so the rate is 5% per year. And then finally, how long will it be worth? How much will it be worth after 5 years? So you usually have to have a period of time. Now, again, if you buy a house, typically they gain in value, especially in Colorado Springs. So we would go A, 1 minus R to the 1 plus R to the T. So this time I'm going to use a plus because it's going up in value. Again, I didn't hear the words continuous or anything like that, so that's why I'm sticking with this formula. So I would go like this. I would just pop in my 85,000. 1 plus, again, be careful, 0.05 to the 5th power. Because you can't put a percent in for R. It has to be in math language. Okay, so I do 85,000 times 1.05 to the 5th. And again, I do that on a calculator, so you need a calculator on these problems. You would get, let me see. I didn't write this all out, but basically if you do this to the 5th power and then multiply by 85,000, my final value, I did this already on a calculator, would be 108,483.93. Now I noticed in the book it said 484. I believe that answer is wrong. I checked this like 2 or 3 times, so I think the book was just off by $1. Okay? So here's the good news. You buy a condo, 5 years later, it's worth about almost 20,000 more, or more than 20,000 than when you originally bought it. Okay? Now, those 3 are not too bad. We're moving on to the tougher problems now. So moving on to number 12, and this is a half-life problem. Now, half-life problems are pretty challenging. I'm going to just tell you. So 12 is going to look like this. The problem reads, a radioactive iodine is used to determine the health of the thyroid in your thyroid gland. If you ever get your thyroid checked by a doctor, they're going to use iodine to help you get that checked. It decays according to the equation. So they give us the equation this time. Y equals AE to the negative 0.0856T. Okay, so they give us this equation where T is in days. Find the half-life of this substance. So they've kind of given us the rate of decay of iodine, and we're supposed to find its half-life. In other words, how long does it take for iodine to, if you have 10 grams, how long would it take it to become 5 grams? That's what it means to have a half-life. Now, Miss Brewer talked about this. You can plug in just about anything for a half-life. Basically, the important thing is that A is your initial amount. So if I say I have 2 grams, then my final amount should be 1 gram. Whatever this number is, this number has to be half as much, okay? So you, instead of 2, you could put 50, and then here you could put 25. And then you do e to the negative 0.0856 t. Now you got to solve this dude, okay? So first of all, whenever you're trying to solve for an exponent, this is when we're going to need logs and logarithms. But we got to get that 2 out of there first. So the first step I will do is I will divide by 2. So I get 1/2 equals e to the negative 0.05856 t. Now I want to solve for t. Now he's up in the exponent and I want to get him down on the ground. So the way I do that is I'm going to ln both sides. Now I could also log both sides, but ln is what you want to use. So we're going to drop an ln in there, okay? And so basically this goes out front, and the ln of 0.5 I can do on a calculator later, but this becomes negative 0.0856 t times the ln of e. Now remember, the ln of e is just 1, so really that just disappears, okay? So all I'm left with is what's on the left here, and so now I divide by negative 0.0856 on both sides, and I am left with, and I put that all into a calculator, by the way. So I do the ln of 0.5 divided by negative 0.0856, and the final answer is 8.09. And remember, this is time in days, not years. So the problem will specify what the time is. So I would say it would take about 8.1 days for that iodine to decrease all the way down to half as much. Now, this is really important, these kind of decay problems, because my wife's a nurse, and I'm going to tell you a lot of things, like when you take ibuprofen, you know, how long does it take to decay? That's important because then, you know, it tells you how long you got to wait till you take some more ibuprofen if you still have a headache or something. So knowing the rate of decay of chemicals and things like ibuprofen is very important, especially in the field of medicine. Okay, so at this point we have about 4 more problems left, and what I'm going to do is I'm going to clear the screen and we'll continue on. Okay, I'm going to try to get one more problem in here, and I'm going to use the rainbow ink. This is problem 15 and 16. They're kind of related to each other, and they're very similar to the one we just did. So 15 says, I may have to go to blue because I'm not sure that's going to work so great. The problem says a bacteria that usually reproduces in a process called binary fission. In this type of reproduction, one bacterium divides into 2. Each in ideal conditions, some bacteria reproduce every 20 minutes. By the way, I think they're actually talking about E. coli. E. coli is a really vicious bacteria that you can get from food, and it does reproduce, I believe, every 20 minutes. That's why you have to be very careful if you get E. coli. Get to the doctor quick, okay? So we start out with this equation, y equals a e to the kt, because bacteria, well, first of all, they mentioned that there's a constant k, so that kind of tipped me off to this formula. Also, bacteria usually grows continuously. Now, this is actual growth this time. So here's what we know. It doubles every 20 minutes. So let me tell you how you would fill this in. That means if you start with 1 bacteria and you have it for 20 minutes, now T is going to be in minutes in this problem, so do realize it's not going to be in hours, it's in minutes. I would end up with 2 bacteria. So after 20 minutes, my 1 bacteria turns into 2 because it splits, and that's binary fission, okay? Now, I have to find K for this particular bacteria, which is kind of its rate, right? So the first thing I would do is that 1 is really just unimportant, so you would just do 20K and 2 right here, and then how do I get that K down to the ground? Well, I'm going to ln both sides again. The reason I do ln instead of log is because there's an E in the problem. So at this point, the 20K goes out in front times the ln of E. This just becomes a 1